Hi, today we're going to talk about operations with polynomials. Okay, we're going to add polynomials, subtract polynomials, and multiply polynomials. Okay, well first of all let's talk about what are these things called polynomials. Okay, well a polynomial is basically just a little expression that's separated by addition or subtraction. Okay, which breaks them apart into these things called terms, which I think you're fairly familiar with. Okay, we'll be talking about a little bit more about this later on here. But if it just has one term, it's called a monomial. Mono meaning one. Binomial is 2 and a trinomial is 3. Okay, so these are all examples of polynomials. Okay, well I have a little list here of what makes something not be a polynomial. Okay, and there's 4 little things. They can't have any negative exponents. So you can't have something like x to the negative second power. No negative exponents. We can't have any variables in the denominator. I can't have 2xy over a, for example. Can't have an a down there. No radicals, no square roots or cube roots or fourth roots. Okay? And we cannot have any variables as exponents. So I can't have something like 2 to the x power. I can't have a variable be up there as an exponent. So those are examples of when a little expression is not a polynomial. Okay, and one other word here before we get going is this is kind of an important word here that we'll be talking a lot about in this chapter, is this thing called the degree of a polynomial. And for the most part, the degree is simply the biggest exponent we see on all of the terms. Okay, I have 3 little examples here. Can you tell me the degree of each polynomial? Okay, I have a couple trinomials. When I look at this first expression here, the largest exponent I see is a 2. So it has a degree of 2. Okay, not 5x squared, not x squared, but it's literally just the exponent. Okay, how about this guy? Okay, there's a 1, but the largest exponent I see out of all 3 of those is a 3. That one has a degree of 3. It's called the cubic. Okay, most of the time when things are written in standard form, as you know, from the biggest exponent to the smallest exponent, it's going to be the first one out front. Okay, but sometimes they change it up and don't always necessarily write it in order. So make sure you always scope them out and look for the biggest one. Okay, and then what about this guy? Okay, it has x's and y's, and it has more than one exponent. Okay, well that's where this little thing up here where it talks about the sum of the exponents coming into play. If I look at this first term, that's y to the first, that one has a degree of 3. Okay, 2 plus 1, the total of the exponents is 3. There's a 1 there, 4 plus 1, that one has a sum of 5, and this one has a sum of 6. Well, the largest total of all the exponents is 6. So I would say this one has a degree of 6. Okay? For the vast majority of the time, we're not going to see ones that have multiple exponents in it where we're going to have to state the degree. Every once in a while. Most of the time, they're going to be just single variables, or the same variable, I should say. Okay? But be careful with these. When there's more than one variable, we have to add them up. Okay, let's try tying some of this stuff together here. There's some examples here, and this example's in your book. Okay, let's try and take a peek at this. Determine if each is a polynomial, so we're looking for yes or no. If it is, tell me its degree. So when I look at this first one, if you think about those 4 criteria that I had there, there's no negative exponents, there's no variables in the denominator, and it's okay to have a fraction, it's okay to have numbers in the bottom. Okay, and remember, these are all over 1, so they're all on the top. So they're all good. Okay? So it is a polynomial, and it says here its degree is 7. Where are they getting 7 from? Well, they're getting 7 from right here, the 4 and the 3. 4 plus 3 is 7. Okay? When I look at letter B is not, because we can't have radicals. Okay? And the number C is not because it has a couple negative exponents. It is not a polynomial. Okay, so that's the first thing you're going to be seeing today. Identifying the degree, or first of all, stating whether or not it's a polynomial, and then finding its degree. Okay? All right, one more. See if you can do these by yourself for a second. Is it a polynomial? Number 2A. It is not. And the reason it is not, because there's a variable in the bottom. This one is a no. Okay? This one over here, though, I don't see any negative exponents, no denominator, no negatives. Okay? But this one is a sum of 6, this is a sum of 7, and that's a sum of 2. The degree of this polynomial, again, is 7. Okay? So not a lot of fancy math so far. Okay, we're going to get to that right here. Okay, so here's an example of adding a couple polynomials. And notice the parentheses. What these parentheses do is they just group them together, and it groups those guys together. And we're going to add those two polynomials. So I have a trinomial and a trinomial, and we're going to add them together. And really all this boils down to is combining like terms. It's as simple as that. Okay? And like I mentioned earlier, we usually like to write our answer from biggest exponent to smallest exponent, what's called standard form. So when I look at those exponents, the largest exponent I see is a 2. They're both x squareds. Well, let's add them. 6x squared plus negative 4x squared is 2x squared. And notice the exponents didn't change. We're just counting how many x squareds there are. If I want to, I can cross them off. Okay, then come the x's. Negative 7 plus 9 is positive 2x. They're gone. And then I have 8 plus negative 5, which is 3. And there would be my answer right there. So adding, just combine like terms. It's as simple as that. Okay? Here's a subtraction one. Okay, same type of thing. I have a trinomial being subtracted by another trinomial. Now subtraction, we have to be a little cautious because as many of you know, what does that minus sign do to everything in the parentheses that are after it? Yeah, it changes the sign on them. Okay? Now some people like doing a change all the way through. You sure can. I personally just leave it. But again, I'm going to combine like terms. I see some x squareds. Okay, a 4x squared and a 2x squared. But now it's 4 minus 2, which is 2x squared. And they're gone. Okay. Then come the x's. Now be careful again. It's negative 5 minus 3. That's negative 8. So it's minus 8x. Okay, and then the place really to be careful is with this last term right here, the constants. It's 6 minus negative 1. And as many of you know, minusing a negative, I can do a change. It's going to turn into a positive 7. So again, I just kind of leave the sign there, and if I see minus a negative, I know I have to do a change. Okay, so subtraction, again, you're really just combining like terms. But be careful of the subtraction sign in front of the parentheses. Okay, so that's not too bad, I hope. Okay, I want you to push pause here for a second. Take about a minute or two and see if you can simplify these. Ready, set, go. Okay, unpause. All right, let's try this again. Okay, if I look at the first one and I combine like terms, I have a negative 1x squared minus 1x squared. Negative 1 minus 1 is negative 2. That should be negative 2x squared. And they're gone. Okay? My x's, that's these guys. Negative 3 minus 2 is negative 5x. And then these two, 4 minus 5 is negative 1. That's what we should have gotten for the first one. Okay, notice again how I draw arrows. Can you draw arrows like that or lines connecting the like terms? Sure, absolutely. Okay, here I have an adding one. And again, I look for the biggest exponent. There's 1. This one doesn't have any x squareds. Well, then the only thing we have is a 3x squared. There's just one term. Here's an x, and it's plus a negative x, which is just negative 1x. That one's gone. And then I have my constants. Negative 6 plus 1 is negative 5. And there's my answer there. So not all terms are going to have a partner to match up with or a like term to combine with. That's okay. Okay? But there's adding and subtracting. Okay, not too terribly bad. Okay? The last thing we're talking about here is multiplying polynomials. Okay? And a lot of this is going to boil down to simply using the distributive property, okay, which we've talked about before. Okay, if I take this number outside, I'm just going to multiply it or distribute to everything on the inside. So 3 times 2, I get 6x, and it's going to be to the third power, because if you remember, I add the exponents. Okay? 3 times negative 4 is negative 12, and x times x is x squared, and 3 times 6 is 18x. Okay, and once I multiply all those together, there aren't any other like terms to combine. There's our answer. So it's simply the distributive property for a lot of these. Okay, here's one more. practice one more. Now be careful, a bunch of negatives up there. If I go here, a negative times a negative is positive 6a to the third power. And again, there's a 1 out here. Negative 2 times negative 11 is positive 22a squared. A times a is a to the second. And then the very last term, negative 2 times 20 is negative 40. And then there's just 1a left over. No like terms, nothing to combine. There we got it. Okay, so again, the distributive property. Okay, how about this one? Okay, it almost kind of looks like a FOIL problem. Okay, but we're going backwards. Okay, well you can do it one of two ways. If I just stick with the distributive property, I'm going to take this one and distribute to everything in the second set of parentheses. And if I do that, n squared times n is n cubed, and n times 2 is 2n squared, or n squared times 2 is 2n squared. Okay? There aren't any more numbers back here for the n squared to multiply, so it's done. I'm going to then take the 4n and distribute it through to everything in the second parentheses. 4 times n is 4n squared. 4 times 2 is 8n. Okay. And then I'm going to take the 6 and distribute it through to everything in the second parentheses. And I'm going to get negative 6n minus 12. So I just took one term at a time and distributed it through to everything in the second polynomial, the second parentheses. Let's look to see if we have any like terms we can combine. And like I said before, I like the biggest one first. I don't see any other n cubes. It's going to stay n cubed. 2 plus 4, that gives me 6n squared. Those are like terms. These two guys are like terms. 8n minus 6n is 2n. And then minus 12. And there we have it right there. Okay, so once again, it's just a glorified distributive property problem. Okay, be careful with your signs and be careful with your exponents. Okay, how about this guy? Okay, this kind of combines a couple different things. It's going to combine the distributive property as well as, it looks like, we're subtracting those two polynomials. Okay, well, let's just do one thing at a time. Let's take this 4 and distribute it to everything there. I think I get 4a squared plus 20a. 4 times 5 is 20, and then 4 times 6 is negative 24. So there's my first one. Now be careful with the second one. You need to ask yourself, what kind of a 3 is that? Well, the subtraction sign makes it become a negative 3. So when I distribute here, let's keep that in mind, that is a negative 3. Negative 3 times 2 is negative 6a cubed. Negative 3 times 4 is negative 12a. And then negative 3 times negative 5 is positive 15. Okay, so we did all the multiplying. Now let's go back and combine like terms. And again, I like the biggest one first. I think I see, there it is right there. And it's a cube. And it's a negative 6a cubed. And it's done. After the third power, I'm going to look for the second powers. And I think I just see one of them here, the 4a squared. Plus 4a squared. And that one's done. Okay, then I have a couple a's. Those two right there. 20 minus 12 is 8a. They're done. And then I just have my two little constants left over. Negative 24 plus 15 is negative 9 if you did your calculator. Okay, and that's it. There's our answers are kind of long, okay, depending upon how many terms there are. Okay, but everything is combined and simplified as much as we can, and it's also written in standard form. Okay, so multiplying, combination of multiplying and subtracting, hopefully it's not too bad. Again, the biggest thing, the most important thing is keeping track of your signs. Okay, all right, I'm going to end here with a couple special ones. 4a squared plus 5. Okay, now many of you know this. What does it mean to square something? Well, to square something means to write it twice. Okay, and multiply it by itself 2 times. Okay, there it is. And it really just becomes a FOIL problem, multiplication problem. If I multiply it out, 16a squared plus 20a. There's another 20a, and then a 25. And if you remember from foiling, it's these middle terms that can combine. Okay, and there we have it. Okay, so just write it twice in FOIL. It's perhaps the easiest way to do it. Okay, same thing with this one. I'll do this one real quick again. I can write another, or I can write 3x minus 4 and 3x minus 4. Okay, and I write it twice in FOIL. I get 9x squared minus 12x. When I do that one, I get another minus 12x, and then a positive 16. If I combine these middle terms right here, negative 12 minus 12 is negative 24x plus 16. And there's my answer. Okay? So that's not so bad. Okay, I got one last one. What if the polynomial is cubed? Well, just like squared, if something's cubed, it means we multiply it together 3 times. So I'm going to have a 2x plus 3, a 2x plus 3, and a 2x plus 3. Okay? And the thing is, how many things can a person multiply at a time? You can only multiply 2 at a time. And it doesn't matter which 2 you multiply at a time. But for simplicity's sake, let's multiply these first 2 together. And if I FOIL those, I'm going to get 2x squared plus 6x plus 6x plus 9. And if I do my middle terms, I get 12x plus 9. And I did that really, really fast, but that's what I get on the left. And all of that stuff then has to be multiplied by this 2x plus 3. Okay, so, oh man, we're going to have to distribute that one more time to everything again. I'm going to scooch up here a second so I have a little more room. Let's try this once. So I'm going to go here first. I'm going to get 4x cubed plus 6x squared. Then I'm going to go to this middle one right here, and I'm going to get 24x squared plus 36x. 12 times 3 is 36. Then I'm going to take the 9 and distribute it through 18x plus 27 way out there at the end. Okay? And last but not least, let's go back through and combine any like terms. And again, the biggest one I see there is a third power. Are there any other cubes? Nope. It's going to stay 4x to the third power. Looks like I have a couple squareds right here. 6 plus 24 is 30. I have some x's. 36 plus 18 is 54 if you were to use your calculator. Oops, sorry, this was x squared over here. Forgot that. These are just my x's, and then last but not least, I have Mr. 27 out there at the end, all by himself. Okay, and there we have it. Okay, so we did a little bit of multiplying polynomials and adding and subtracting polynomials. Good luck. Thanks for tuning in.